province is well known for its festivals. In fact, here in Iloilo, we have the well-known, world-renowned Dinagyang Festival. A similar festival is also held in Cebu, and that is the Sinulog Festival. There are similarities between the two, and to compare these two festivals, we can use this diagram. The yellow portion may represent the characteristics that are common to both. Well, we can include in there the celebration centers on the child Jesus, the Santo Niño, and we have here the blue portion, the region that represents the characteristics that are unique to Dinagyang. Another portion, the darker blue region, represents the characteristics of Sinulog Festival, which are unique to Sinulog. The comparison of those two festivals makes use of concepts in sets, in particular set operations. I am Rosemary Felleman, an assistant professor at West Visayas State University. Welcome to my channel, and today we are going to learn different set operations. First, let's talk about union. The union of two sets, A and B, denoted by the symbols shown on the screen, is the set of all elements which belong to A or B. That is, A union B is a set containing X such that X is an element of A or X is an element of B. Take note that the colon is read as such that, and X here is simply an arbitrary element. So it is not a particular element, rather X is used here to represent the elements in the set A union B. And such element X has the characteristic that it may be in A only, it may be in B only, or it can be both in A and B. That is why we have a note here below that when we speak of or in the definition, it is used in the sense of and or. We have here a diagram showing A union B. The shaded region, the region that is in yellow, represents the union of those two sets. Remember a while ago that the union may include the elements that are both found in the two sets, or it can be simply the elements that are found in A only or the elements that are found in B. There are cases when a particular set is contained in a larger set. We can see here a yellow region being contained in the blue region. Well, the union will simply be the blue region itself, now shaded in red. There are also cases when two sets do not have common elements, and so the union will simply be the two sets. Now let's have an exercise. If we are to find the union of A and B, where A is comprised of letters that are found in the word Dinagyang, so we have set A is the set containing the elements D, I, N, A, G, and Y. And we also have set B containing the letters of the word Sinulog. So set B is equal to the set containing the elements S, I, N, U, L, O, G. Now let's find A union B. We have this set. How did we find that answer? Now, D must be in the union. I must also be in the union. There is no need to write I twice, even though I appears in both sets. So you just have to write common elements once. That is also true for N. We also have A in the union, as well as G, Y, S, U, L, and O. So we did not miss any letter at all. By convention, we can write the elements in a particular order. For this case, we have the set with the elements written in alphabetical order. We also have the intersection of sets. As defined, the intersection of two sets A and B denoted by A intersection B is the set of all elements which belong to both A and B. That is, in symbol, we have A intersection B is equal to the set containing X, such that X is an element of A and X is an element of B. Now, as you can see in the illustration, A intersection B is shaded. Let's have an exercise. Let's find the intersection of these two sets that I presented a while ago. All we have to do is to look for common letters or common elements. So we have A intersection B. Note that the intersection of disjoint sets is an empty set. Disjoint sets do not have common elements at all. Let's talk about absolute complement. These two symbols are read as A complement or the absolute complement of A. This is a set containing X such that X is an element of the universal set, but X should not be found in A. In the illustration, the region that is shaded with pink is representing the set A. The region shaded by white represents the complement of A, or the absolute complement of A. What kind of operation is involved in this illustration? Let's find out. Oh, it's relative complement of B with respect to A, otherwise known as difference of A and B. We have some portions of the set A being shaded. So what does this shaded region, the region shaded with pink, represent? In symbols, this is the difference of A and B. It contains the element X such that X is in A, however, X is not in B. Here is another interesting diagram. It looks like a butterfly. We can get that by getting the union of both sets and subtracting the intersection, as shown here in the screen. So we have here the symbol. It looks like a cross with a circle. So we get this particular region by getting the difference of A union B and A intersection B. This is the symmetric difference of the two sets. By definition, symmetric difference of sets A and B is the set containing X such that X is an element of A union B and X is not an element of A intersection B. So once again, the symmetric difference of sets A and B is the difference of the union of two sets and the intersection of two sets. Let's have this example. Let us use roster notation to show the required sets. The universal set is the set containing the integers from 1 to 10. Set A has the elements 1, 3, 5, 7, and 9, while set B has the elements 4 and 9. Let's find A complement, the difference of set A and set B, and the symmetric difference of A and B. I will give you time. Now let us find A complement, or the absolute complement of A. This is the set containing elements that are found in the universal set, this one, but the elements must not be found in set A. So element 1 is found in the universal set, but it is in A, so we will not include that in the complement. We have element 2. We can include it here in the complement. Element 3 should not be in the complement. 4 must be here because it cannot be found in A. 5 should not be placed here. 6 must be included. 7, no. 8 must be included. 9 should not be included. And finally, we have 10. The work may be easier if you can find the common characteristics of the elements. For instance, in set A, we can see that these are odd numbers from 1 to 10. And so we know that the complement of A must be the even integers or even numbers from 1 to 10. Next, let's determine the difference of A and B. The best thing to do is to list the elements of A first. So we have 1, 3, 5, 7, 9. I am just replacing A with this set, and I'm going to replace B with this set. I'm using the roster notation so that we can easily see what elements will be left if we are going to take out elements that are found in B. So 4 is not here, so we have nothing to delete. 9 is here, and so the final answer is the set containing 1, 3, 5, and 7. Now let's proceed to the last one. This is the symmetric difference. The best thing to do is to find the union of the two sets and the intersection as well. So we get the difference of the union and the intersection. So I'm going to list first the elements in the union. We have 1, 3, 4, 5, 7, and 9. So we just simply included 5 in the set. We just simply included 4 in the set, not 5. We just simply included 4 in the set in order to come up with a union. And then we subtract, quote unquote, subtract the intersection. The intersection must be the set containing the common elements. For this case, we have the element 9. And next, we get the difference. What will be left? We now have the set containing 1, 3, 4, 5, and 7. So this is the symmetric difference of A and B. The last one is the Cartesian product. Cartesian product is essential in understanding higher mathematics concepts. Let us have this definition. The Cartesian product of two sets A and B is the set A cross B, A times B, or Cartesian product of A and B of all ordered pairs X and Y, such that X is an element of A and Y is an element of B. Take note that when we speak of an ordered pairs, we are looking into the pairs of elements, objects, numbers, or letters. But we have to take note that the order is important. So if we have the pair XY, this pair is different from the pair YX because order is important. That is, A cross B is the set containing the ordered pair XY such that X is an element of A and Y is an element of B. Let's have this as an example. We let S sub 1 be the set containing the elements A, B, and C. S sub 2 is the set containing the elements 1 and 2. Now let us find the Cartesian product of S sub 1 and S sub 2. All we have to do is to list all the ordered pairs wherein the first element must come from S sub 1 and the second element must come from S sub 2. Now here's a tip. We can use the fundamental counting principle that we have learned in statistics in order to determine the number of ordered pairs in the cross product or Cartesian product. All we have to do is to multiply the number of elements in the first set by the number of elements in the second set. So S sub 1 has 3 elements. S sub 2 has 2 elements. We multiply 3 by 2, we get 6. So as you can see here, we have 6 elements in the Cartesian product. We have the ordered pair A1. We also have A2, B1, B2, C1, and C2. In this video, you have learned about the union, intersection, complement, difference, symmetric difference, and Cartesian product. I hope you will be able to use these concepts when you compare different festivals here in the Philippines, and I do hope that soon we will have an opportunity to attend these festivals in person. Stay safe and healthy.